Okay, this is number 16. I think it's 4.7, number 16. Okay. Biologists stocked a lake with 400 fish and estimated the carrying capacity, the maximum population for the fish of that species in the lake to be 4,900. The number of fish grew to 620 the first year. That's a big hint. Find an equation for the number of fish, P of t, after t years. So what we're using in this problem is the carrying capacity formula, and that's going to be the population at time t. It's going to be c, the carrying capacity, over 1 plus a e to the negative bt. Now, c is the only one that's easy to get. Everything else can be a little bit of work. So c, that carrying capacity, is 4,900. That's going to be over 1 plus a e to the negative bt. So let's get our a. We can do that. A has to do with the initial amount of fish, but it's not the initial amount of fish. So the formula c over 1 plus a will equal the initial amount of fish, which was 400. Now, just to be clear on this, how do we get just a? Well, if t, that time is 0, b times 0 is 0, e to the 0 is 1, so that's why we have 1 plus a. And so we have 4,900 over 1 plus a equals 400. So I'm going to multiply both sides by 1 plus a. So I can change colors here. And we have this reduces with that. And I'm going to go to blue. I like blue more. So we have 4,900 equals 400 plus 400a. I just distributed the 400 there. Subtract the 400. And we have 4,500 is 400a. And we can divide both sides by 400. And we have a equals 11.25. Okay, I can scroll this up, keep on working here. So our formula is going to be P of t equals c over 1 plus 11.25 e to the negative bt. Oh, I forgot that. C, we know what that is. That's 4,900. Okay, so we're at 4,900 up on top. Now, let's continue. We want to find out what b is going to be. So if you look back at the problem, it says find an equation for it after t years. And what they tell us is that after 1 year, it's 620. So p of 1 is going to be the 4,900. Nice if I wrote the right thing. 4,900 over 1 plus 11.25 e to the negative b times 1 equals, what was that, 620? 620. Okay, now we're going to do some algebra and come up with what b is. The only unknown of this entire equation is that b. So we have 4,900 over 1 plus 11.25 e to the negative b equals 620. Multiply both sides by 1 plus 11.25, and not enough space. One plus 11.25 e to the negative b that divides out, and we have 4,900 equals 620 plus 6975, that's a 9, times e to the negative b. And we can subtract 620 from both sides. And we have 4280 equals 6975 e to the negative b. So we can divide both sides by 6975. And e to the negative b would be equal to 4280 over 6975. And we take the natural log of both sides, and that would cancel. So negative b would be, what is that natural log going to be? Natural log of 4280 divided by 6975. I get negative 0.4883793,181. So b is just the positive of that. 0.4883793,181. Let's see if I can go to the next page. I don't want to do that. Okay, got more space to work now. So our formula is going to be population at time t is going to be 4,900 over 1 plus 11.25 e to the negative 0.4887793,181 times t. So then the problem asks, if I scroll back up here and delete, let me get this moved up so they can go a little further. Whatever. Okay. When's the population going to be 2450? So we are going to take, I lost my, oh, just disappeared on me. Our population at time t is going to be, what did we say? It was 4,900 over 1 plus 11.25 e to the negative. Now, I know my calculator, I'm sure, stored more than what they showed on the display. So that's my go-to is to refer to the calculator as much as possible. E to the negative 0.4883793,181 t. So we want to know when this is going to be 2450. Now, when I do a problem like this, I really try to do as few calculator actions as possible, meaning I like to get the things condensed down into one overall expression and throw that in the calculator, because that eliminates, or I shouldn't say eliminates, it minimizes round-off error. Okay, so one approach to this, I'm trying to solve for this t here, the only unknown. We don't know the time it's going to take. And it's going to be a little bit of a work to get that out from being so isolated. I mean, it is isolated, but trying to get that by itself. So you could think of this as cross multiply and divide because you have a fraction situation. I mean, you could do this as 4,900 equals the 2450 times the 1 plus 11.25 e to the negative 0.4883793,181 3793181T. I guess you could distribute that if you want. Then 4900 is 2450 plus 27562.5 e to the negative 0.488379381T. Subtract that 2450. Oh, surprise, surprise, it's 2450. Haha. Is equal to the 27562.5 e to the negative 0.488379381T. Then I'll divide by this coefficient. That divides out. And I have this 2450 divided by 27562.5 equals e to the negative 0.488379381T. We're getting closer. So how do we undo an e? We'll do a natural log. So the natural log of both sides of 2450 over 27562.5 is equal to, taking that natural log, negative 0.488379381T, and then we can divide by this negative 0.488379381. And that should be our T. So I'm going to put this in the calculator. Now I'm going to rely as much as I can on copying values into the formula. So natural log of my 2450 divided by, and I'm going to scroll up to that 27562.5, close that parentheses, divided by that negative 0.488379381, and I get my answer. T equals 4.955918564. I think they said go to two places, so 4.96 should work. This was the answer that they had in on their answer key. That should work though if they say two places. Or you can say 4.9559 if you want to be a little safer, but that's the idea. Okay, well, I hope that helped.